Hi, class. So I'm doing this video to help you write the equation for a quadratic function. So let's see what that looks like. A parabola passes through the point 7, -39, and has a vertex of -3, 11. Its line of symmetry is parallel to the y-axis. Find the equation of the parabola y equals, okay? So there is a general formula for the parabola that has such vertex, and it looks like this. Y equals ax minus h, and then squared plus k. Right, so we know this is the equation when hk is the vertex. So the x coordinate of the vertex is we call this h term, and the k is the y coordinate of the vertex. So if a parabola has vertex -3 and 11, then all I would do to find the equation, or the first step that I would do to find the equation, is just plug in the given vertex numbers in for the h and k. And then we're going to have just one unknown here, really the a. So I do that. I plug in and this is what it looks like. So I just replaced the h with what was the x coordinate of the vertex, which was -3. And I made sure that I am substituting in a negative number. So I put it in parentheses, and I know that I have a negative sign coming from the fact that there's just a negative sign in this function, and then a negative sign in the fact that it's a negative number I'm plugging into. So do a double negative here.
I just saw a fisherman with a dog. Barking so loud.
All right, so now we just simplify it. It becomes x plus 3 in parentheses squared plus 11. So I can just like double check this, that if you have already practiced, hopefully you've already practiced with an equation that looks like this, you know how to graph it. If you know how to graph an equation that looks kind of like this, then you would recognize that the vertex is going to be the opposite in sign as that you see in the equation. So the vertex in this case would be -3, 11, which it is. So I know that I kind of did that math correctly there. Okay, so I can go back and forth. You know, I can I can plug my vertex into the function. I mean, into the h and k where it needs to be, or into the equation, you know. And then I can also, once I am finished with the equation, I could be like, okay, well, if I graph this, where would the vertex be at? And just double checking yourself that it would graph what you were trying to get to graph. Okay. Now you're like, well, I still have this variable a, and the x and y are fine in the equation here. They're dummy variables. Do we need an x and y in when we write an equation? But the a we don't want. So how do we get rid of this a? Well, the cool thing is they gave us another point, another piece of information here, and it is an x coordinate and a y coordinate. So one thing that we can do is we can plug in that other given x coordinate and y coordinate, and that would give us, and this what's cool about this equation is when I plug in this x and y, it should be balanced. That means this side of the equation should equal this side of the equation. And if I plug in x and y, the only unknown that I'm going to have is the a, and I'll be able to solve for a. So I just go ahead and plug in the 7 where I see the x and negative 39 where I see the y. So 7, this becomes and negative 39 over here. And now I can solve this equation for a. Like I said, so it's 7 plus 3 squared. So that'll be 100 squared plus 11, which equals to negative 39. But then what I do is 100 squared. Oh, no, oops, 10 squared. That's what I meant. I was going too fast, right? I did the 10 squared. Okay, that which becomes 100a plus 11 is all equal to negative 39. Now I subtract 11 from both sides. Negative 39, and you add in another negative 11. Now you add them together, so that's 10, 4, 5, 50, and negative 50, right? And then so 100a is equal to negative 50. I divide by 100 on both sides, and I get a is equal to negative 50 over 100, which reduces to 1/2, right? If I divide the top and bottom by 50, I get 1/2. Negative 1/2 is a. So now I can rewrite the equation how it should be, because I knew what the h and k were already, but then I plugged in the x and y just so I could figure out the a. Now I can go back to this general formula, and let me erase everything else. And I can plug in now the a that I know has to be true, and that point truly lies on the line. That it has to be balanced equation. Then the a has to be negative 1/2. Then the x I'm leaving as a dummy variable now. I know I plugged in numbers for it before, but the x and y don't determine a particular equation. We need to leave a dummy, we call it dummy variable x and y, so that we can plug values in. That's what equation is. We plug values in, find values for, plug values for x, find values for y. So we need those dummy variables so that we can use this equation later on. But there's certain values like the a, the h, and the k that determine a specific type of equation, type of parabolic equation. In fact, the h and the k determine where that vertex is taking place, right, in the Cartesian coordinate, and then the a is affecting how steep the sides of the, is it steep, or how steep or how flat the parabola is, right? The sides are. So the a, h, and k are all describing specific or characteristics about the parabola. So I plug in the negative 3 again, and then the 11, and then that still becomes x plus 3. I'm sorry, squared. There was a square on this. That's the hardest thing in math sometimes, just making sure to rewrite what you have already written above. And this, I believe they should be happy with this equation. And let's just double check. Yep, negative 0.5. There we go, they're happy. Now they ask, when x is 17, what is the value of y? Well, that's what this equation is doing. It is all set up to give us y if we are given a particular x value. And I like to describe that in terms of, by using the word in terms of. So this equation, given an x, we subtract, it's negative 3, and then we square it, and then we multiply by negative 1/2, and then we add 11. and we get a particular y value that comes out for every given x value. So then they're just asking, hey, what about for this one particular x value? What's my value of y? So we just plug in for x. Let me rewrite this, so taking away the double negative there and simplifying it. So I just plug in for x what they said it was equal to. So x equals 17. What is the value of y? So 17 that's negative 1/2, and that's 20 to the second power plus 11. So 20 squared, it means 20 times 20, which means 2 times 2, which is 4, and then I take the two zeros and add them down. So it's 400. Then times by a negative 1/2, that would cut it in half and then multiply it and make it negative. So it would be negative 200 plus 11. Wait, to do this more, to just, I think it's really important to write down each of your order or operation steps, because it's reinforcing to you to do this step first, then do that step next, So 20 squared, that is 400. And then 400 times negative 1/2, that is negative 200 plus 11. See, if I'm trying to do all these math facts in my mind, then I'm more likely to make mistakes. And when I'm done with my work, if I made a mistake somewhere, it's gonna be really hard for me to track it and not just erase everything and start all over again. But if I see this work, you're like, and you can look from here and look back to there and say, well, where did this negative 200 get? Maybe I made a mistake in that calculation. You can redo it in your calculator, negative 1/2 times 400, because that you can visually see that everything in the equation was the same, except for the negative 200 is now here, and then negative 1/2 times 400 was there. So you know where the negative 200 came from. So it's really important to keep really organized. It helps you keep all this organized in your mind. All right, so then 200 is negative 200 plus 11. So you're going to subtract and then keep the sign of the larger number, which happens to be the negative. So we have y equals negative 189. So let's just double check that's what they get, negative 189. And they ask, lastly, what is the average rate of change over the interval x equals negative 3 and x equals 17? So I think I've mentioned to you guys before that the rate of change is just the slope. And if you're talking about a straight line, then the slope is the same throughout the line. Let's just say that this little ramp is the slope. And when you pick up that ramp and you measure it all, you're using the same ramp will fit, and it fits. That steepness is the same everywhere on this flat line. It should be. Okay, but when you're looking at so the slope with a linear equation, or you did in algebra 1, that's just natural. Okay, but now we're looking at a parabola, and this is not where it's at negative 311. So it's -3. So let's just say it's up here. Vertex and let's just say that this is what the parabola looks like. Well, these are not straight lines. So like I would have to, let's say these 2 points are given. Say this is at x equals -3, and I'm not sure if it is, or that's at the other place in 17. Oh, that's not gonna be right, but like, you got the idea. Then I need to find the slope between those 2 points. And when it's at 17 and at x, as if it was a straight line between those 2 points. So I hope that you're very well aware that the slope formula is the change in y over the change in x. And let me just add the little subscripts on here. Basically, you take one point and you start the x and y values of the other point. That's the slope. Well, they give you in this problem just an x and two x's. So the question for me is like, well, I know for the slope, I can find the slope if I have two x values and two y values, right? Then I can label them. One's x1, y, the other one's y1, the other one's x2, y2, right? And I can substitute into this formula, and I'm very good at doing that because I've done lots of problems like that. But my problem right now with this, they're asking for the slope, and I don't have the two, I don't have the y coordinates of these values. So what I have right now, I can call this my x1 and that my x2. I have the x value, so I'm going to plug in for x1. And I have an unknown y value, and then I have a x2 value, which I'm going to plug in 17, and then I have an unknown y2 value. So the question becomes, well, how do I find these y values? Because if I found the y values, then I would be able to just plug into this nice slope formula. I would subtract two y values, subtract two x values, and then have my slope. So how, given an x value, how do I find the corresponding y value? All right. Hopefully you picked up from this second part of the problem, if I'm given x equals 17, then to find the y value, we're going to do exactly what we did with that problem. We're going to plug in our x value. If I want to find the corresponding x value, because every x value has a y value that belongs to it. So given one particular x value, I'm going to get a particular y value. So I'm going to do this problem I'm going to find the y1 by plugging in the for x -3. So really, these are two problems, just like this middle problem that we have to do. And hopefully that's familiar with you. Remember a long time ago, I call it the table method of graphing. You plug in, you pick any value, usually 0 for the x, you plug it in, you get into the y equation, for x, you plug in the 0 in for x, and then you do all the math and you simplify and figure out what the corresponding y value would be for that given x value, right? So we're doing the same thing. I'm plugging in this -3, but not into this equation, into my known equation. Where is my known equation? Up here. It's -1/2 x plus 3 squared plus 11. So I'm plugging in -3. So let's see what I get. So anytime you just substituting something in, it's a good idea to put it in parentheses. -3 plus +3 is 0. That's dandy, right? I like that because I don't have to square anything, any big numbers. Squaring really makes big numbers fast, quick. So 0 squared is just 0, then multiplied by -1/2. That's just 0, and then I get 0 plus 11, and then I just get 11. So when I plugged in x equals -3, I got 11 for y. Then now I'm going to plug in the second one, the 17. Oh, we already plugged in the 17. That was the answer to this part. And I can't recall what we got. Well, let's do it again. I think we got -198. Right? Oh, you can see another example of how to do this. Okay, so now I plug in the 17, which we just did this a few minutes ago, but I might as well, it only takes a few seconds, and you can just verify that I'm gonna do the exact same thing as I did with the -3. 20 squared we said was 400. And then 400 times -1/2 is 80. Okay, I'm gonna first multiply it by +1/2, which would be 2, and then multiply by negative, and it would be -200. Just easier to do in my mind like that. Which would be -189. 189. So that's what I plug in. Okay, so now I have all of my points I need to use this slope formula. All right. So now I'm plugging into this slope formula. So you have to be very careful here. So plugging in for y2, I'm going to plug in this -198. And it's a good idea to put things in parentheses when you substitute them in. And for y1, I'm putting 11. X2, I'm putting in X2, I'm putting in 17, and X1, I'm putting in -3. So the big mistake that students make is they think, oh, look, there's a negative. This is a negative that comes from the formula, and there's a negative coming from the fact that this number, in fact, was negative. So both of those negatives need to be written in here. So then I end up getting -198 minus 11, which is going to be we're back to 189. Oh, these are small things that you have to look real closely at those little tiny mistakes that can be easily made. That's going to be -200 in the numerator. Then I'm going to get 17 plus 3 on the denominator. So it'll be 20. -200 over 20. And then that's just -10. Right? Because -10 times 20 will be -200. And there we go. Let's see. Let's just double check this answer. -10. There we go. All right. I hope this made a lot of sense to you. Have a great day. Bye.